Hello guys, welcome to my channel. So today I'm going to start working on Geeks for Geeks problems. I think you guys are familiar with Geeks for Geeks. It's I think a really popular platform. This video is going to be on detect loop in linked list, and this question has been asked in a lot of companies. There are FANG companies like Amazon, Facebook, Adobe. But there are more companies like Accenture, Nagaro, like service-based companies, and they also ask these questions. So these are not like completely based on the knowledge experience of Amazonians, but these are the questions which are being asked in almost all of the companies. So let's see what we have to do. So the problem says that we have a linked list of n nodes, and the task is to check if the linked list has a loop or not, right? So what is a loop? So that's the question, right? I hope you guys are familiar with the linked list, and I think loop is also really a generic term, but in case if you don't know, a loop in a linked list is a condition that occurs when the linked list does not have any end. So usually linked list ends at a pointer where it is pointing to null, but when there is a loop or cycle, it doesn't actually ends, right? So there is no end. So there could be a loop like 5 and then there is a loop, right? So it goes on and on. So that's how when you see a cycle, so you see like after 6 it is coming back to 2. So this is a loop, and this is what we have to detect, right? So how should we do it? So logic is that we will use two pointers, slow and fast, and these two pointers are going to be initially pointing to the head as in our first node. So if you see here, this is our head node, so initially they are both going to be here. After that, what we need to do is we need to move these two pointers at their pace. So slow pointer, as we have called it slow, it is moving one node at a time. A fast pointer is moving two nodes at a time, that is why it is fast. And we have to check if in case they both meet at any point, there has to be a loop, right? Why do I say that? So if a pointer is moving at a certain pace and another one is pointing, like making two jumps, the second pointer is moving at a faster pace, so ultimately it is going to come back to the first pointer, and if it comes back to the first pointer, there is a loop, and that is what we are going to do in this logic, right? So just a demonstration. So this is a linked list and this is a cycle or a loop, you can say. Initially our slow pointer and fast pointer are both pointing at 8. So when we do the first iteration, our slow pointer is going to move at 1, and the fast pointer, which was here, is going to move 2 nodes, and now it will come at 9, right? In the second iteration, our slow pointer is again jumped 1 node, but the fast pointer jumped 2 nodes, that's why it is at 2. And this is going to be the same case in the third iteration. Now it is at 4 and the fast node is 7, and I think you might have guessed. So the fast pointer now is at F and the slow pointer is at 2. Now in the next iteration, they both are going to meet at 3. So that's how we got to know that there is a cycle. So this is the demonstration, but now let's do a practical. So let's come down to this logic here. So there's a method where we have to return true or false based on if there is a loop or not. So what I'm going to do is, they have already provided us the node implementation, so I'm just going to create two pointers here. So my first pointer is slow, which is initialized to head. Same goes for fast, initialized to head. Now I'm going to check if my fast point, if in case there is no loop, my fast pointer is going to be null at some time. So I want to check that null condition so that I don't have to iterate in that case, because there is nothing to iterate over. So I'll just do fast.next not equals to null. So this condition is for when there is no loop in the linked list, but if there is, it is going to come inside. And then we have to move our slow pointer one node at a time and the fast pointer as 2 nodes at a time. Okay, now we just have to check for the equality. If they both are meeting at any point, then we'll just return true, otherwise it is going to return false. And this is it that we have to do. So if you try to compile this code, it is going to run the first test case. So it is true as expected here. So 134 output true. When you try to submit, it is going to work fine, as I have already tried this, so I'm pretty sure. So it says correct answer. Now I'll show you another logic. So this is like a logic which you will see very frequently and everywhere in each and every website. But my point is, an interviewer, when there is no virtual interview, or like when I used to give interviews, they usually were face to face. Now because of COVID, they are virtual. Point is, an interviewer always tries to find multiple solution, or he or she will try to see if you can solve a question in multiple approaches or not. So there are two ways more. One is using set, another is using linked list. So I'll try with the list, the set first. So I'll create a set of node, name it set, and then I'll do new hash set. And then what I'm going to do is, I'm going to iterate over my linked list, just like we are trying to display each and every node. So I'll just iterate over my head till it reaches null, and then I'll check if my set. So if you know about set contains unique or distinct data in its data structure. So in case if there is already an entity, so like we demonstrated here, if 2 was already there and cycle comes back to 2, that means that there is a cycle. It won't insert, but it will check for the condition if set is containing that element or not. If it is containing, that means that there is a loop. So first we will fill 8, then 1, then 9, then 4, then 2, then 3, then 7, then 2 again. So if there are duplicate elements, right, it is also going to I think that's a fail case scenario. But if there are distinct element, and then you have to check for the equality, in that case you can use hash set. And then there is one more way, linked list. If you create a linked list here, then you again have to do the same thing, right? So what we will do is, we will just check for the equality, as in we will do set dot contains, and then we will do head. If it is containing, then we will return true. If it is not, then what we will do is, we will first add to the set. Okay, we will do head, and then we will do head equals to head dot next. So now if you try to run this, it is also going to work fine. So true, try to submit. Okay, so it's working fine. So these are the two ways that I got in this question, in these test cases. But like I said, there could be more scenarios that could be failing for this approach, so you don't have to use it. But in case the interviewer asks you this approach, because he is not going to give you the test cases for sure, so you can give this approach. but there could be more approaches, and I just got to know about these two, so I just showed you these approaches. And this is it for this video. I hope you have learned something new, and I forgot to say this before starting on the video, but if you are new to my channel, if you haven't subscribed to my channel yet, please do. Have a good day, stay safe, and bye bye.